We are a frequency control component manufacturer, Taitien Electronics. In this video, we will explain how to perform the matching test for quartz crystal and oscillation circuit. Also, the test items need to be carried out. Through this test, we will demonstrate how the quartz crystal can work under a stable oscillation environment. The following instruments will be used in this test. You could use instruments with similar functions also. In this test, we will use Tektronix oscilloscope, Pico test frequency counter, HP digital multimeter, network analyzer from Advantest, and Tektronix current probe. And here are the major items need to be measured. First, it is the crystal's frequency and drive current on the circuit. Next, it will be the crystal's parameters. And then we will adjust crystal's frequency to meet the frequency on the circuit to obtain the low capacitance on the circuit. Then we will calculate the drive level and negative resistance. This is a standard crystal oscillation circuit. The red dotted line represents the oscillator IC or chipset. The rest are the external oscillation circuit with two capacitors connected to ground. Through measurement and calculation, we can understand whether the oscillation circuit environment is stable or not. First, we measure the frequency of the crystal on the circuit. We use a current probe and frequency counter for measurement. From the picture, we can see that when using a current probe to measure, it is necessary to let the current to pass through the hole on the current probe. We can reduce the influence of the load on the crystal frequency by using the current probe. Then, we can get the oscillation frequency of the crystal through the frequency counter. The current probe method is also adopted when we use an oscilloscope for measurement. Through the oscilloscope, we can observe the frequency signal and current signal detected by the current probe. The oscilloscope shows that the vertical axis is the voltage scale, and the measured RMS voltage value needs to be converted to become the RMS current value. In order to further understand the characteristics of crystals, we need to remove the crystal from the circuit and measure it. We use a network analyzer to measure crystal's parameters, and the equivalent parameters will be obtained. Then, we use the network analyzer to obtain the low capacitance and perform a crystal frequency test. Adjust the crystal frequency to be the same as the frequency originally measured on the oscillation circuit. You will get the value of the low capacitance on the oscillation circuit. The parameters measured above are the drive current, the crystal's parameters, and the load capacitance. Calculate these parameters for drive level. After obtaining these drive level parameters, we can understand whether the drive level of the crystal in the oscillation circuit is appropriate or not. Finally, we need to measure the negative resistance of the oscillation circuit. Before measuring the negative impedance, a variable resistor and a current probe must be connected in series to the quartz crystal and the circuit. Connect the current probe to the oscilloscope for observation. Then adjust the variable resistance. During the adjustment process, the oscillation signal change can be observed through the oscilloscope. When the oscillation signal stops, the adjustment of the variable resistor stops. Remove the variable resistor and use a multimeter to measure the resistance value. By adding the resistance value to the crystal equivalent resistance value, the negative resistance parameter on the oscillation circuit can be obtained. The drive level of the crystal and the negative impedance of the oscillation circuit may affect the crystal's lifespan and oscillation stability. Common oscillation failures are caused by these factors. The suggested range of each parameter is provided in this video for your reference. We hope you find this video useful. Thanks for watching.